write iOS apps. That's what I do for a living, and that's what I do for our hobby. And one of the things I like about doing my own apps is that I get to use, normally when you do an iOS app, people use bitmaps. If they need a bit of artwork, it's a PNG. But I like to do things a little bit differently. I like to use SVG files. And in particular, I like to use SVG files that have very simple, clean, vectored objects in them called paths. So here, for example, is a bit of SVG that generates my Florog logo for generally helpful software. And so you see there in white we have the boilerplate stuff about SVG. That's an XML file and how wide it is, and so forth. But in yellow we have a path, and a path is composed of some parameters like how wide the stroke is, and but you'll see there's a D parameter, which is a series of letters and numbers, and those letters and numbers make a shape. And this is what we're going to be talking about today. What is SVG? SVG is a vectored file format, which means that if you keep scaling it, it keeps being smooth and beautiful. SVG is an XML format, which means that you can, if you know what you're doing, you can open it up and read it. SVG is something that's in every web browser knows how to render. So if you drop an SVG file on Safari or Chrome or Internet Explorer, Firefox, whatever, it should be able to render it. And while I am going to be talking exclusively about SVG rendering paths, it can have text, it can have bitmaps in it, which sort of ruins the point, and it can have shapes that are not paths. It can have circles and rectangles and things like that. But we're mainly going to be talking about paths. Now, you could do something pretty complicated with paths. You can, although this does have a few circles in it. You can make these you can make things with the gradients and transparencies and different effects like that, and end up being having a fairly complicated document to generate your image you're intending to make. Okay, so if I want it, what is a path? Okay, a path is basically a curvy line. If you look it up, you'll see that it's a series of commands, and the commands have various number parameters after them, and you string them together and you get a shape. And you can apply various strokes and fills and other styles to it to make it interesting, or try to recreate the graphic that you want to do. Here is a list of the commands. If you see an M, it means move to. An L means the line to. A horizontal means a straight horizontal line that goes left to right. A vertical line goes straight up or down. There's a curvy lines, the C for cubic spline, and you can also have something called a shorthand cubic spline, which is an S. You can have a Q, which is the quadratic spline, and the T, which is the shorthanded quadratic spline. And finally, almost all paths, or many paths, will have a Z, which means to close the path. Okay, so now that's the part where I start making a demo. So I open up my app, and so I want to explain. First of all, the most basic command is a move to, because every path has to begin with a move to. So I'm going to move to a point. Let's say I can move to a specific point, like I can type in 30, 20. Okay, now once I've done there, now I want to actually show something on the screen. I'll try it by drawing a line, which is an L. And an L is just that. There's an L followed by the x coordinate, which in this case is 247, and a y coordinate, which in this case is 145. And I can just keep on making lines, and I can make shapes like that. Now, let's say I wanted to make a straight flat line. I could make an L with a with, where the y coordinate doesn't change, or I could just use an h and say I'm going to draw an h to x equal 122. Or I want to draw a line that's straight up and down, so I'm going to draw a vertical line to up to -22 or down to 381. I could just draw like an Etch-a-Sketch and have fun all day long making flat lines. Okay, but I probably don't want to, I probably occasionally want to make a curvy line. So the first kind of curvy line that I would normally try is the quadratic. And if I draw a quadratic, you'll see that I have a endpoint, like this one in yellow, and a control point, which sets with a curve. So like my example here, I say, well, if I move to 0, and then I draw a line with a control point of 20, 20, which means x equals 20, y equals 20. And then I will end up with a smile. Now, on the other hand, if I draw it with the control point above the line, I will end up with a frown. Now, if I put the control point close to the end point, it's really curvy at the end point, and it's hardly curvy at all at the start point. And I can do the other way around, where it's very curvy at the start point and hardly curvy at the end point. So you can see, you can just play around with it. You can get a feeling for what the control point actually does. Now, sometimes you'll notice that the quadratic takes 4 parameters. Well, sometimes in a very long path, you might be thinking, oh, this is taking up too much space. Is there anything I can do to save space? And there's such a thing as a T, which is a shortcut quadratic Bezier. And you'll notice that I don't have control over the control point. It's calculated for me. If you look at it, you'll basically see that what they do is they take the control point from the previous quadratic and they just reflect it across the endpoint. So if it's way over to the left on the previous one, it'll be way over to the right on the generated one. It won't move. It's sitting there. I don't use it very often. It's sort of not it's not my thing. Okay, so what is my thing? I like the cubic Bezier. And you can see here that when in the cubic Bezier you have 2 control points. And so you can make all sorts of weird shapes with that. Yeah, so like if I move it really close to the point, I will curve it a little bit. If I move way over here, it bulges away over there. If I move this way over there, I ended up, making a big S. It's sort of fun. And so like if I enter this example here, let's see what happens when I enter this example. 60, 52. So this is supposed to make a heart. And so one of the things that I like to do when I'm doing my own graphics is I like to actually type things in, so I get it very precise. So if I have a star, and I know mathematically where all the parts of the star are, then I will type them in as opposed to drawing them out by hand. And I feel that I get a very precise look to my graphics if I do it that way. If I've actually typed in the mathematical points of the graphic, so and I can get a beautiful symmetry that way, because like in this case, this particular heart is perfectly symmetric because I've set the control points such that the one control point is symmetrical with its corresponding one over on the right side. And I end up with a nice little heart. Now, obviously, there's also a corresponding shorthand version of this, which again, I'd actually never use. But, I mean, presumably some people could find it useful. So you can see that with the shorthand version of the quadratic, the first control point is calculated, and the second control point is still under your control. So, I don't know. I do not know what you would use that for, but it's there. Anyway, but here comes the hard part. Making an arc. So let's move to somewhere. Let's see, 100. Okay, I want to draw a half circle, and I want to draw a half circle to let's say I want to go to 100, 0. Okay, so a half circle at 100, 0 would mean that it's had a radius of 50. So I give it a radius of 50. So there are two parameters, the x radius and the y radius. And if you're making something that's circular, those would be equal. If you were making something that's a little bit more oblong, like making it like that, you would give a different radius and a different x radius to a different y radius. So you can make fairly complicated shapes that way. And I guess I should do it that way so I can demonstrate the next thing, which is you can tilt it. So you can enter an angle in degrees so that you can tilt your the sweep of your arc. I don't do that very often. It tends to be sort of confusing, to say the least, how to do it. And most things you would end up doing with that, you would do with a cubic anyway. But it's in there. You can tilt it. Now there's a parameter here that is a flag. It can be either 0 or 1. And the first one is it's a long sweep, which means if I were making like I've had this shape, and I want to say, oh, I don't want that shape. I don't want the shape where the gray scar goes all the long way around. I want it where it goes a short way around. So it'll make me an arc that goes from the begin point to the end point, and it will take the short way. Now, on the other hand, maybe I want to go counterclockwise, in which case I will set the next flag to go the other way. So now I'm going this way. Now, if I can set so you can see that it is not the most natural thing in the world how they set this up. And another problem is that if I make an arc that begins and ends at the same point, which maybe I want to make a circle, oops, it can't do that. Or it gets really confused when it tries to do that. So oftentimes you'll end up saying, oh, okay, what if I went to just a little near it? If I draw an arc that begins and ends at the same place, it's going to get really confused and it will often disappear. That's the point. So anyway, so I made a little egg shape. It's almost a perfect circle, oval, but it's going to end up at 99 instead of 100. So the arc is really useful for making circles or whatever. But what I normally do if I want to make a circle, and here I'll tell you how this little trick of the trade, is I will draw a half circle. And then I will draw the corresponding other half circle that are good to go back. That's just normally what I do. It's easier that way. So, and then I will use a a closed path. Now, this gets us to the closed path. Let's say I draw a line, and then I draw another line, and I say, oh, I wish there was an easy way for me to draw a line back to the beginning. Well, there is. That's what Z. It will draw a straight line back to your most recent move to operation. Now, let me undo that. Now, let's put a fill in this thing so we can see the fill on that. Okay. So the fill knows that it's going to do that. It's going to draw right to that. That's good. Let's say that I draw it like that. I can make a funny little monster shape, whatever. Now I'm going to hit a Z and close it. Now you can continue after that Z making other shapes. So let's say I want to make a little circle here for its eye. Ah, look at that! Isn't that cute? That I drew a shape, and because of how how this thing treats interior subpaths, it cut a hole in this other shape. That's pretty cool. And then I can say Z, and I can move to another thing, and I can make it, let's say I want to make a little triangle or something. That'll be funny. Okay, so I made a little triangle, but what happens when I go the other way? Oh, it didn't cut a little hole there. What's the deal with that? Okay, what the deal with that is, in this outer shape, you'll notice I'm going counterclockwise. And in this eye shape here, you'll notice I'm going clockwise. So if I have this path set up to do even-odd rendering, it knows that a clockwise shape inside a counterclockwise large exterior shape will cause a hole to be driven. But if I have another counterclockwise or clockwise shape inside of it, it doesn't really know what to do with it. It draws its stroke, its outline, but it will not draw a hole. That's sort of an interesting thing. Now, let's talk about. I've been using my little app here, but let's say I'm in a bit of SVG in an actual app, and you'll oftentimes notice that there is no L. You'll be typing around. You'll be looking in the SVG, and instead of saying, M00 L1020, there is no L. You think, well, what does that mean? Does it mean, why does the move have an extra couple parameters? And it's implied. There's this concept in SVG of an implied command. And so in this case, an M followed by a series of numbers will be interpreted as move, line, and then keep on going, line, 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 until you actually put in a command. Similarly, if I move in and then I draw a cubic Bezier, and I keep on typing numbers without any intervening command, it assumes that I just want to insert a series of cubic Beziers. And so generally the idea here is that they want to save space. They didn't want to have the most bulky format in the world, so they said, yes, if you just keep on typing numbers, the most recent command will be the one that is assumed to be there. Unless the most recent command is a move, in which case it will be assumed to be a line. And then, yeah, like I said, Y to make the file smaller. Okay, now I said earlier that there were, however many commands, but it's not true. There are absolute and relative to commands. So if I type in an uppercase M and I'll move to 2050, that's absolute. But if I type in a lowercase m, it will move relative to the current point. So oftentimes when you're building things up, especially with arcs, which are tricky, and you want to be able to have the flexibility of changing its starting point. You will use a lowercase thing because you'll be able to move around more freely. And so all the commands that have an uppercase and a lowercase command, and they will behave differently accordingly, except for Z, because capital Z or lowercase z, all both do exactly the same thing, which is close a path. So I should probably demonstrate this here. So I'm going to demonstrate that here. Okay, so you might as well start off with an absolute move command. That's fine. Okay, but I'm going to draw. Okay, so I'm going to draw way over here. Okay, I drew a relative path. And then I'm going to draw something else and, just draw stuff. Okay, now I'm going to go back up. So I have a move command followed by a series of relative commands. Well, what happens when I change the move command? It all goes with me. See? It doesn't change the shape. Now, if I did the same thing with absolute commands, and I went back and I changed the original point, you'll notice all of a sudden it's changing the shape of everything, because when I use the relative commands, it doesn't care where it starts, basically. But if I use absolute commands, it will distort the image because of that. And so oftentimes when you're doing a drawing, anything, and you got it just the right way you want it, and then you realize, oh, I should move this I over here, or something like that. And then you realize, oh no, I got to retype in all that code because it's all in absolute coordinates, and oh, if I'd only used relative, it would have been so easy. Okay, so here's some interesting stuff. Let's see. So let's say I have this familiar shape, and what can I do with it? Let's see, I can change it to be hollow. So I have a fill of none. Or I can have a fill of, black or gray, really light gray. I could have a stroke width which is very narrow. And oftentimes when I'm dealing with this, I will go over to my text editor, and I will launch my text editor. Okay, so I can change the fill to some other color. Let's say green. I can say, current color, which is really cool because that means that I can make. Let's say I had a whole series of objects of shapes in here, and I wanted to have the flexibility to change its color. I can do that. I can change its opacity. So I can make it transparent. I can do all sorts of things. It's really cool. One of the things that is fairly unknown is this whole idea of the you can have a vector effect non-styling stroke. So let's say I scale this thing down. Okay, I scaled that down. Now I scale it down some more. And I think you will notice, right, that the artwork is getting smaller, but the line is not. And that's pretty useful when you're scaling stuff down to a little bit, because your lines tend to get, well, they tend to, you can't see the lines anymore. So if you scale a piece of artwork down to a small space, like, you know, you have a button or something like that, you basically want to set the stroke width to be a constant to the extent you can. So I usually set the stroke width to 1, and of course it's not working for some reason here. But anyway, in general, there's some cool things you can do with it. Anyway, I hope you enjoyed this video. This is one of my first videos, as maybe it's obvious. My name is Glenn Howes. If you're interested in the app I was using to demonstrate with it, it's called the SVG Paths app. I sell very few copies of it. And it's available in the Apple App Store. And you can check it out there. Anyway, I hope you learned something about the SVG Paths and that you'll be able to use them in your own projects. Even if you're not using my tools. It's a cool technology, and I really enjoy playing with it. Thank you. Have a great day.